Hello everyone, welcome to Coder and Boots. So in this video, we are going to discuss about the topic how to create your own Linux command. Okay, so and it can be also termed in this way, how to create a binary of a shell script. Finally, when we say like a Linux command, it's basically a binary. Okay, so internally it has some functionality which was implemented in some code, through some code, but for the end user it is exposed as a simple command. Okay, so let's get into the topic. So these are the following things that we are going to discuss in today's session. So one is what's a binary file. Okay, so what is Linux command, how to create our own binary, and how we are going to create. So basically we need a utility for doing or creating our own binary. That's called shell compiler, because we'll create our own shell script and we'll compile it using the shell compiler. Okay, and then we'll do all these in the practical part session. Okay, so let's discuss what's a binary file. So you might have heard about this term binary file, right? So binary file is basically a file which has machine understandable the code, or the code which is readable by the machine. Okay, so your code is like a high level code. Whatever we are writing is a high level code, and then we compile it and create like a binary file, and that binary is something that is readable by the machine. Once you open the binary file, you will not be able to read anything. Okay, it's you will feel like some encoded or encrypted kind of content, but the system will be able to read the binary file. Okay, that's a simple definition of what is a binary file. Okay, so then next is what is a Linux command. So you might have noticed several commands in you are familiar with a lot of commands in Linux, like ls, cd, right? Then sum, right? There are a lot of default built-in commands. Also there are some pluggable commands as well in Linux. So what are these commands? So when you dig deeper into the commands, you will see there will be some executable inside the /bin or /usr bin folder of our Linux machine. Okay, so USR bin directory of the Linux machine. So what is that? It is basically a binary. Okay, so somebody might have already written the definition, the detailed definition of the individual command. That is how it is functioning in the way you want. Okay, let's say ls means it is doing a listing of all the files, okay, in a very user friendly way, and ls accepts several arguments, right? So that means definitely there is a code behind it that is performing this task. Similarly, each and every command will have a code behind it, but for the end user it is just a binary executable. You just type the command and it is available in the machine. Okay, so what we are trying to do here is we'll try to create our own command. Okay, so let's create our own command. So let's say you are doing some complicated mechanism or complicated activity, and you wanted to automate that and create it in a, or do it in a simple command, so that you can share that as a distributable to everyone in your team or in your company, so that they also don't have to do that tedious task. They can just use this command to perform that activity. Okay, so that is what we are going to do. So this can be achieved by using a utility called shc. Shc stands for shell compiler. So thanks for the developers of shc. So this shc can be used for compiling our shell script to a binary, and we will put that into the usr bin folder so that it will become a command. That's the goal. So let's get into the practical session. Okay, so as usual, we'll go back to our black screen. So this is my Linux machine. I'm using an Ubuntu machine, and so what we are going to do is I'm going to create a shell script to multiply numbers. So you can create any shell script of your choice. So you can, depending upon your requirement and your use case, you can use any shell script. For simplicity of explanation, I'm going to create a shell script for multiplying number. So finally the goal is for me, I wanted to multiply numbers by simply calling a command mul, and then numbers I'll pass it as arguments. I want the product. That's the goal. So I have my shell script already created here. So this is mul.sh is the shell script. Okay, let's open the shell script and understand what is inside this. So here, this is a simple shell script. So I have a variable product. The value I have initialized to 1. Okay, then what I'm doing is I am iterating over the the arguments that I get as to the shell script, and I am iterating over it, and here I am checking whether it is a numeric argument, because I want only numeric arguments, numeric inputs to my shell script. That's why I am verifying whether it is a numeric input, right? Then if it is not, that's why using this regex I am verifying whether it's a number. If the input is the argument, the dollar at the rate means it basically iterates over, like I mean the using this for loop, it iterates over the arguments, and for each argument, okay, I am checking whether it is a number, and if it is not, then what I am going to do, I am saying, okay, if it is not, that's why like I am using the exclamation mark here, if not number, then please enter numeric inputs only and exit the script. Okay, else continue, right? Else continue, and what we are doing? We are doing product equal to product into that number, right? Initial value of product is 1 and product equal to product into that number, right? And then it iterates over all the arguments, okay? And then what it will do? It will say done. That's the goal, okay? And another thing what we are doing is we are just doing a validation. If product, the final product equal to 0. So what all scenarios, like I mean the product will become 0. One is, let's say like I mean if there is something wrong with this. Second is something wrong with the input, or second is if you put any 0 as like I mean the argument, one of the numeric input, right? If it is 0, what will happen? It will be, product will be 0. So that's why we are giving a message, please execute the script like $0. $0 means, I mean, what is the 0th element? That's the script itself. And then 11, 22, 32. That means, I mean, in this way we can have any number of arguments, but the executable or the command has to be used in this way, and make sure the inputs are non-zero numbers. Okay, and then exiting. Finally, we are printing the product. The product is the value of the final product. Okay, so same way you can create the command, I mean the scripts for addition, subtraction, okay, anything depending upon your interest, you can create it. Okay, so this is my simple shell script. I have my shebang at the top, bing bash. Okay, this is the bash script. So now I have it here. Now next thing is I have to install the SHC utility, apt get install SHC. Okay, so this is in case of Red Hat machine or CentOS or Oracle Linux, you can do yum install SHC. In my case, it's a Ubuntu, so I use apt-get. Depending upon your package manager, operating system and package manager, you can use that. It will be available in the repository. So you can also compile the SHC from the source code. Let's say you are using a different variant of Linux where you don't have available it as a package, installation package. What you can do is you can go to the SHC's GitHub and get the code and compile it yourself in the Linux machine. That also will work. Okay, so now I already have the package installed. That's why it's showing SHC is already installed and it's to the latest version. So now what I'll do is let's see what is there in SHC. SHC-H. It gives us like I mean the possible options available with SHC. There are a set of options available, like the usage they are saying like -e. Okay, E means basically what? Expiration date. Okay, so SHC, if you use -e with a date, what will happen? It will create a binary that expires on a specific date. Okay, let's say if you want to create a command or a binary that expires on a specific date, you can specify the date, right? Then -m, message to display upon expiration. So let's say after expiry, you can create your own custom message to display after the expiration, right? But if you are going to create a generic script, you don't really need to pass these arguments, right? Because you are creating something which is not going to expire. It depends on your use case itself. Then -f, file name to the shell script to compile. So whatever shell script we are creating, we'll have to compile it, right? So in our case, what is the shell script? It is mul.sh. Okay, so then there are a lot of other options, output file name, right? Relax security. Some of these we'll go through some of these options in this video. So first let's quickly get the binary created. Okay, SHC, and our option is -f mul.sh. Okay, after executing this, let's see what happens. It takes a while, and you see once we execute, it creates two other files. Okay, one is a file with extension .x, second is a file with extension .c. Okay, and what we need is basically the file with extension .x. Okay, so as we saw in the previous options, if you have given the -o argument, we could have created the final binary created in whatever name we want. Okay, so as we have not created, what happens? By default, it will create two files with the name, the shell scripts file name .x and .x.c. Okay, see, this contains a C program and this contains the binary. So what I am going to do is I am going to move this to something which doesn't have the shell script or H. So I'm just creating mul. I'm just renaming this file from mul.sh.x to simply mul. Okay, so this is a binary executable. So I have something called mul. Now what I'm going to do is I'm just going to test this mul. Okay, I'm just going to pass some arguments 1, 2, 3. Okay, so I am executing this binary by passing 3 arguments 1, 2, 3. You see, the product is 6. So depending upon your choice, you can make it like very user friendly. Okay, so there are a lot of things, lot of fancy things you can do in shell script, adding like the help option, like various argument options, right? And results also you can print it in very nice way. Let's say if you want to do something else with the result, you can do that. All those you can do it depending upon your choice. Let's say 1, 2, 3, 4. Okay, you see, product is 24, right? So that means it is executing, but you see it is not functioning as a Linux command again, because I still have to manually execute this binary from this location, right? So what I'm going to do is I'm going to copy this. So in order to add this to this mul to the path permanently. So if you see mul, there is no binary or executable available in the machine. Okay, you see command not found, right? So what I need is I need a command itself with mul. So what I'll do is I'll copy mul from here to /usr local bin. Okay, so this is the place to keep all the custom binaries, right? Now we have our file inside usr local bin, right? Now what we'll do is, let me clear the screen. Now I came out of this folder itself. Now I am typing mul, then 1, 2, 3. You see, product is 6. Now I can switch to a different user itself. There is a different user in this machine like CIB. I am getting inside the user account. There also I am just using mul 1, 2, 3. Okay, you see, product is 6. That means in this machine I have added my own binary. That binary is doing the product of numbers. So whatever numbers you pass, it will do the multiplication. Let's say I am passing my customer number, anything like this. You see, it's doing the product and it is giving the numbers. Okay, similarly you can also create your own script. Now let's discuss some more details about this binary. Okay, so as we discussed, there are multiple options available in the shell script, right? When we created the binary, there were multiple options, right? One was expiry. Expiry means, let's say you wanted to share something and you don't want that to be used by someone for a long time. You wanted to kind of a license. You wanted to create the binary only for 30 days. Okay, so what you can do is you can set the expiry for that particular binary. So I'll show, let me delete this binary and this one. So we'll create it again. So shc-h, let's verify the option again, -e-m, right? So and the date has to be given in this format, dd mm yyyy, right? So what I'll do is I'll create a binary with a previous date. Previous date means so that I can show the expiry message, right? So let's type current date. Today's date is 13th August 2024, right? I'm going to create something with the date which is maybe 10th August 2024. Okay, so what I'll do is shc-f, okay, -e, I'll do 10/08, right? Then 2024, okay, -m, okay, I'll pass something like contact renewer. Oh, I'll just put renew your license. New. Okay, please renew your license in this case. Okay, and -f, I'm creating mul.sh. Okay, so now this time it created the binary, right? You see mul.sh.c, right? Let's rename it to mul.sh mul. Okay, now we have the mul here, right? So I'm not going to copy to usr bin and all because I just wanted to demonstrate this, right? So mul, right? Then 10 20, I'm just passing two numbers. You see mul has expired, please renew your license. Okay, because it's showing, because the date I have given was a previous date. Today's date is 13th August. I have given an expiry date for 10th August, so that means it's already expired, right? But if you give like a proper expiry date, it will work, right, till that date. Once it reaches that date, it will stop working. Okay, so like this, I mean, you can create your own custom message as well. Then next option is by default, whatever binary that gets created here. Right now this is created in Ubuntu machine, so whatever binary that you create here, it won't work in a different machine. Okay, let's see whether it works or not. So what I'll do is I'll copy. I have a different machine available over here. Okay, so that is my Kali Linux. So let's see the IP address. Okay, if config. So the IP address is 192.168.1.137. Let's copy to this machine and see whether it works or not. So we already have usr local bin mul, right? Then this is the source file and target is Kali at 192.168.1. It's 1.137, right? 192.168.1.137 colon. Okay, so we are copying the, yes, enter the password. Now you see the binary is copied to the other machine. It's the same binary. So in the other machine, let's see whether it works or not. So here if you do ls, you can see the mul is over here, right? Let's try to execute mul. Okay, mul 10 20. Okay, you see it's not working. It's giving some random character, right? Weird characters. So that means it is not working. Okay, the reason is the binary that you created over here, it is not distributable. Okay, so you need to create a redistributable binary. So there is an option over here, you see -r. That means relax security, make a redistributable binary. By default it is secured and it is kind of I mean created in such a way that it cannot be shared to any other machine. Okay, but if you want to make it shareable, what you do, use -r. So what we will do is, let's create a distributable binary. Okay, so it's shc-f then -rf. Okay, rf, then mul.sh. This is a distributable binary. Now let's see ml. Okay, this one we will do mv, creating this, and on the target machine I am going to delete whatever I have copied, rm mul. Okay, now it's deleted. Now what I'll do from here is scp. Well, just up arrow, and I'll just copy this using scp from this machine to the other machine. Okay, copied. Now in the other machine, let's see. So we have the binary over here. So /mul, right? Then mul 10 20. Right? See, the product is 200. It's executing. So this is a different machine. This is a different operating system as well. So this is Kali Linux and the other one is Ubuntu. Okay, so now my binary, I am able to copy my binary to any other machine. So in this way you can distribute your binaries to any number of machines. Okay, and here also you can set the expiry, right? And there are further options available in this one. If you go back, you can see there is something called make it untraceable. So if you create a binary with untraceable, so what will happen is, like, I mean, the traceability will, by default it is no, but if you make it with -u, it will block the traceability. So that means it will not, the system calls and all, whatever is happening within the script, right, it will not be traceable, okay, so by anyone. So it will be, again, we can say like a it will be, let's say you are creating something like a licensed software where you want to share it with the end user, but you don't want to you don't want them to know anything about your script. So in that case you can use -u so that they will not be able to trace anything about it, right? And then so instead of like renaming the file manually, you can specify output file name, so with -o option, so that it directly creates a file. Then verbose, like while creating the while doing the compilation, if you wanted to do with verbose, you can use -v. So like this, there are several other option, right? So you can specify these options based on your choice. But I think in this video you learned how to create your own shell command or shell binary. Okay, I hope this video is useful. So if you have any questions, comments, feedbacks, feel free to comment below this video. I'm happy to help you. Thank you very much for watching this video.